good day, everyone, and thank you, TechBlik, for the opportunity to deliver this speech about recent developments in Nanosilver inks at Agfa. To be honest, I like this fast concept, like getting a little bit through the BS and go directly to the essence. So I will lose no more time and move on to the next slide, if that works. For some reason, it doesn't work. Yeah, here it is. So I can show here that Agfa already has a long history in graphics, which over time developed into strong capabilities in inkjet solutions. In the first place, inkjet solutions for graphics. But we have more in-house technologies that can be used in functional inks, and with that I mean conductive inks. No time to talk about our excellent P.PSS conductive polymer technology, but let me highlight the benefits of using nanosilver for conductive circuitry. First of all, nanosilver offer a huge increase in silver efficiency. You need 2 to 3 times less silver metal to do the same job. So the obvious benefit is to reduce the impact of the high silver cost, as we are seeing nowadays on your BOM. On your bill of materials. Using less material should always be a goal for everyone, but even more so in these roller coaster times where commodity prices are only going up. And there is an additional benefit in using nanosilver. You have more sintering options like near infrared or IPL. And this will also limit your energy use, which is another equally precious resource nowadays. Secondly, with nanosilver, you can print finer features, which opens the door to transparent touch electrodes, transparent heaters, dense printed electronic circuits, just to name a few. The benefit of that, of course, is apart from the transparency, which, for instance, other speakers also highlighted for antennas, is the road to further miniaturization. And I think we've also seen some nice examples of that already. While all of the above benefits apply to all of our inks, I specifically also want to highlight the advantage of using inkjet printing for printed electronics. First of all, there is less waste of precious materials as inks are not exposed to the environment during the printing. And secondly, they don't have to be reclaimed after use. And on top of that, we have all of the known advantages of inkjet that other industries already have embraced, rapid prototyping, lot size 1, variable data, and personalization, to name the most important ones. And finally, and that's also important when you compare to other printing and processing technologies, inkjet offers a unique combination of large format combined with high local accuracy and high throughput. So, and here I'm happy to make the following announcement on TechBlik. We have regrouped all of our conductive nanosilver ink under the Prelec brand now. Here you find the overview. There is, of course, no time to discuss the details. I've only highlighted a few in red, but you will find all of these details on our shortly to be revamped website. So that's a work in process. Just the highlights, we have our workhorse screen printing ink, the SIP 2000s, which is still around. Then we have 2 solvent-based inkjet inks. One is established. This was the SIJ20X, is now SPS 201, and a newer version, SPS 210, that I want to discuss in the next slide to show some advances that we have there. Then we have a water-based inkjet TPS 303. And then finally, not a conductive ink, but a companion ink, which is UV curable dielectric with high breakdown strength. And here in 2 graphs, you see actually the way the resistance of a printed track decreases over time at 3 different fixed temperatures. 150 C, which is more or less our standard temperature, then 130 C and 110 C. And this is brought into the graph for both our existing ink SPS 201 and the new ink SPS 210. And as you can see, we have achieved a dramatic improvement in the required time to sinter the ink at a given temperature. So this opens the door to using this ink in situations where the maximum temperature is limited, or conversely, you can reach a fully sintered track in a much shorter time. For the remaining time, I want to briefly show some developing applications with our inkjet inks, but for that, I have to say we have to rely on what our customers are doing, and then for reasons of confidentiality, I cannot show you very detailed pictures or discuss in detail. But on the left anyway, you see thin film PV metallization with inkjet printed fingers, which are finer than 80 microns. And on the right, you see a transparent heater on plastic glazing, so not on glass. And this heater offers rapid and homogeneous heating. And with that, I come to the end of my elevator speech. I hope you like it, and do come to our booth in room 9, or get in touch with your questions or requirements for your conductive circuitry. Thank you again, and have a good day.